Hello, Year 11 students. Welcome to the first part of our Year 12 content. These weeks are going to be broken up into a few topics. First of which is going to be on data. Now, I'm not sure how far we'll get into the other topics, but at least with this topic, this is what we're going to be covering. So, a quick review on shape, mean, and standard deviation, normal distribution, standardized scores, or in other words, z-scores, review of the least regression data, transformations of data. This is about bivariate and then least squares regression with transformed data. So that sounds like gibberish to most of you guys probably, but it's okay. Once we get into some of the reviews, a lot of this should still be fresh or should come back in your mind. All right, so let's get into it. We're going to start with a review of univariate data. So for univariate data, if you've forgotten what that refers to, it's data that involves only one variable. Started this in chapter 2 of year 11 this year in term 1. So you've got different types of graphs that can represent univariate data, but remember it's all pertaining to just one variable. We also learned about types of data for univariate. So you've got numerical and categorical data. Okay, so I'll put that in here, numerical and categorical data. Okay. Very cool. So numerical data refers to data that's numbers. You can pull out mean, median, and modes from them, and the numbers that actually represent something. Whereas think of categorical data as descriptors, so mainly words or things that describe other things. So such as could be like the most popular food, or could be the colors that people like. Okay, that's categorical data. Whereas numerical data could be things that you measure, like the weight of something, or if you're supposed to count how many siblings there are in a family. Okay, so that's this type of stuff that we learned for univariate data. We also looked at histograms, box plots, frequency tables, that kind of thing. All right. But in this focus, we're going to be looking at mainly histograms and dot plots for now as a bit of a revision. So if you look at these bits of data, these are histograms and they have certain shapes. Okay, so these shapes refer to the way that the data is being distributed. So if your data looks like this, then it's negatively skewed, where it starts low, then it goes up. If it's something like this, where the mean is sort of in the middle, like that, or you could say the median as well, then this is approximately symmetrical. And if your data starts high, then it goes low like that, then it's positively skewed. Okay, we learnt about how to put as well dot plots on our CAS. Now, instead of me reading this for you, I will actually just do it for you guys here. Okay, so on my CAS, I'm going to pull up some data for you guys. Let's get rid of this. I'll come up with some random ones. And I'm just going to, remember on your CAS, or to do this if you've forgotten, go new. Actually, no, let's not go new. But you're going to go new. And then when you do, you get asked to pick what sort of graph or what thing would you like to put. So this is what will come up. You're going to put lists and spreadsheets. Okay. And that's what I've got here. All right, so let's put some data in. I'll copy this. Maybe it says score, so I'll put that in. All right, score. Put some S's. You can call whatever you want, but let's just put our data into this. 1, 1, 2, 2, 3, 3, 3, 3, 4, 4, 5, 6, and then an 8. Okay, there's my data. Okay, and then from there you go menu. Oh, sorry, not menu. Control I. And then you get data and statistics. Okay, and then if you've named your data, if you click down here on the x-axis, you should be able to pick it. So scores SSS, and there's my dot plot, same as this one. Okay, so that's how you do a dot plot. So if you've forgotten how to do that, go back and watch the video again. Okay, so that's how we put a dot plot. All right. If you wanted to, so for some other things that you could also use your CAS for is if you wanted to find the mean of some data and the standard deviation. Now these two are very important. They're going to come up a lot with our the next few parts of this lesson. So going back to our CAS, if you've got your data here, if you want to find your mean and your standard deviation, just a heads up as well, your mean in the CAS is symbolized with this, and your standard deviation looks like this. Okay, so let's put that in. To get that here, we go menu. Okay, oh, one more thing, sorry. Make sure your cursor is somewhere on the right here. Okay, don't put your cursor here. I found that sometimes if you do, it overwrites your data. So just put your cursor here somewhere on the right, maybe just there. Then we go menu, statistics, stat calc. Okay, and then one variable statistics, because we're just working with one variable for now, univariate. Number of lists, yep, we'll go 1. Okay, here, important again that you label. Okay, I can't show you there, but you've labeled your columns. So I'm going to find the mean and standard deviation for scores. Leave that to 1, leave that, and go OK. And now what we can see here is that the mean, remember the mean in the CAS looks like this, x with a dash, is 3.461454. And the standard deviation, right there, SX. Remember on the CAS, the SX symbol represents standard deviation, 1.98391. Okay, so there's my mean and my standard deviation right there. Easy. Now we use these, okay, the mean and standard deviation, they're appropriate measures of center and spread, obviously, when your distribution is symmetric. So only when your data, okay, mean and standard deviation is important and useful when your data looks like this. So this is what we call your standard distribution. Okay, it has to look like that. All right, and I've just shown you guys how to find it, so we'll skip that. All right, so let's do an example here. The maximum temp in degrees of a number of consecutive days in the same location is recorded, and the results are given below. So here's the results. Part A, we're going to draw a dot plot. Part B, describe the shape and of the distribution. So the shape, remember, is positively skewed, negatively skewed, or approximately symmetrical. What percentage of days had a temperature of 30 degrees or above? Round your answer to 1 decimal and write down the mean and standard deviation. All right, so part A, let's do it. On my CAS, I've cheated actually on this because I've already put the data in, so I'm not going to put it in for you guys, but I assume that you guys all remember how to put it. If you forgot, again, rewind the video and watch it back. But because I've already done it, here, this is called, what do I call this? Temperatures. So here on my CAS, I called it temp C, so it should appear. There you go, there's my data. All right, and I'll leave it like this. Yeah. So you can see it side by side. So I've got my data in already. Again, double check that you've gotten all of your data in there and that it's the correct numbers. Okay, that's really important. You do that. If you get one wrong number, and your data will be stuffed up. Okay, now we need to draw a dot plot of the data. Now you can actually just do this by hand if you really wanted to. If you're really lazy, just use the CAS. I would use the CAS because it's just a lot easier. So I wouldn't say that's lazy, but you know what I mean. Okay, so from there, you would go Control-I, data and stats, and then here we're going to put temp, okay, because we want to make it into a dot plot. There's my dot plot. Okay, I'm going to actually use this. I'll put it in here for you guys so I don't have to redraw it. But that's what your dot plot should look like. Okay, our dot plot should look like this. Okay, so again, making sure that if you do a dot plot by hand, I would suggest just do it on the CAS, as it is a lot easier. But if you do it by hand, do not skip any numbers. So that's what my dot plot looks like. Okay, there it is. Part B. Describe the shape of the distribution. Now I can see that the distribution for this sort of starts high, then it goes down like that. So I would say this is positively skewed. Okay, this is positively skewed data. And again, if you can't remember the skews, look at the examples up here. So if your data starts high and goes down, like what we have here, it's positively skewed. Part C, what percentage of the days had a temperature above 30 degrees? Round your answer to 1 decimal. Now, this one is slightly tricky, okay, because there's a couple things you need to know. How do you find a percentage of something? And also, how many dots are there? Here, we need to figure out how many are above 30 degrees. So I can see, if you look at the temperatures, you've got 1, 2, 3 that are above 30. Now, in terms of how many altogether, I believe there's, if you look at your CAS actually, that'll tell you. Here we've got, on the left-hand side, 16 numbers. So there's 3 out of 16. So that means 3 out of 16 are going to be above 30. Now, you've got to turn this into a percentage. Okay, so to do that, you just go 3 over 16 times by 100. So on your calculator, nice and easy. Let's add a calculator. Oops. Control I. So 3 divided by 16 times 100. And that'll give us the percentage of how many are going to be above 30 degrees. Now, if you get a fraction like this, just press Control Enter and it'll give you the decimal. So 18.75. 18 point, it does say 1 decimal, so we're going to round it to 18.8%. And then part D, last bit there, is write down the mean and the standard deviation. Remember, mean on the calc looks like that. Standard deviation is SX. Okay, and then on my calculator, let's find that. So we're working with this data here on temp. We go menu, statistics, stat calc, and then we go one variable stats. Okay, remember we're looking for temp C, so there it is. And there's my mean and my standard deviation. Okay, so let's put them in. So my mean is 25 point, let's see, does it ask us to round? I don't remember. Nope, it doesn't ask us to round. We'll just do 2 decimals then. 0.6, 25.06, and the standard deviation is 5.09. Okay, easy. Okay, let's do one more example on this, and then we'll get into the tricky stuff, which I hope you guys will not get lost in. So, similar example, you've got your data, number of students surveyed about the number of hours they studied on the previous weekend. There's the data. Let's draw a dot plot, describe the distribution, what's the percentage of students that studied for 3 hours or less, and then write down the mean and standard deviation. So let's do that. On my calc, again, I've cheated already. I've put this in previously, so I'm not going to put the numbers in manually because I've already done it, and I've called it hours, I believe, or maybe not. What did I call this? Or maybe I called it study. I can't remember. Nope. Okay, well, I guess I'll have to put the numbers in for you guys. Well done, Tadio. Okay, so if you forgot how to put the numbers in, remember, start by putting in, at the very least, the name of the column, or else this is not going to work. So you've got 0, 0, 1, 2, 2, 2, 2, 3, 3, 3, 3, 3, 4, 4, 4, and then 5. Okay, there's the hours. Now, to make this into a dot plot, oops. So to make this into a dot plot, remember you go Control I, data and stats. Make sure you've labeled it. Oh, I've called it study hours. That's all right. Okay. Hours. There's my dot plot. Okay, so you're going to literally copy this into your answers. Okay, so this will be your answer for this part. So the dot plot, again, you want to make sure you draw it properly. Do not skip any numbers. Make sure all the numbers are there. So that's part A. Part B, let's describe the distribution of this. Now, this one is a little bit debatable. It is a bit trickier, I guess, to, in some ways, make a definitive answer. But I would say this is mostly negatively skewed, not quite symmetrical. And the reason I say that is because most of your data is found on the left side of where your mean and median might be, okay, which is about here somewhere. So in that case, it should be negatively skewed. Okay. All right, part C. what percentage of the students study for 3 hours or less. Okay, so it's 3 or less. So that means you're looking at these dots here. So that would be 1, 2, 5. What's it? 5, 9 plus 5 is 14. Students out of how many? 14 plus another 4 is 18. And just to double check that you have 18 numbers. Yes, so we have 18 numbers. Let me see there. So 14 out of 18. So turn that into a percentage because that's what it's asking. Yes, so you're going to go 14 divided by 18 times 100. Okay, so 14 divided by 18 times 100. You might get a funky fraction. So press Control Enter. 77.77. I think it says 1 decimal. So 77.8%. Okay, were 3 hours or less. Part D, find the mean and standard deviation. All right, let's do that. All right, so here, again, make sure your cursor's on the right, somewhere there. Menu, statistics, stat calc, one variable. Okay, we're gonna go hours. Okay, and okay, there's your mean, standard deviation. Okay, so let's write them down. So for part D, my mean was 2.38. 2.38, and my standard deviation is 1.41. All right. Hopefully that's all made sense to you guys, and no one is having issues keeping up as of yet. But if it hasn't, again, make sure you just go back and watch some of these examples. All right, let's get into the meaty stuff. Now, normal distribution. Remember, when I talked about normal distribution or standard distribution, it talks about data that has a normal or standard distribution. It looks like a bell curve. So a bell curve referring to data that looks like this, basically. Okay, and it's a natural thing. So if there's a natural order to some things, you'll find that there is a bell curve such as this. Now, where you'll find this sometimes, this kind of data, is with your SAC scores, for example. Most of you guys will have SAC scores somewhere in between here. Those that study hard, really, really hard, might have really high scores here, and those that are super smart probably find them somewhere here. Students that maybe didn't study very well might go somewhere here, and students that failed might be somewhere here. Okay, so you'll find that in a SAC score setting, you'll find this sort of thing as well happening, which is your normal distribution. So normal distributions can have different centers and spreads, but again, they all have the same shape, which is a bell curve. Sometimes you'll find data that's very much grouped like this. Other times it's a bit more spread out like this. Sometimes you'll find data that's higher on the scale, so on the higher end, but again, still keeps the bell curve. Okay, normal distribution is completed by determining its mean and standard deviation. So these two are very important, which we learned how to find here. The mean and standard deviation on our CAS. So you need to have your CAS for this. All right, so let's get into this part, the 68, 95, and 99.7 rule. Okay, there's a simple rule connecting the mean and standard deviation of a distribution with a percentage frequency of a range of values. So what are these numbers? What is the significance of these numbers? Well, these numbers actually represent the distribution of your data and where you can find it. Okay, so that'll make more sense here. So 68, 95, 99.7 rule. Now that applies again to data that looks like a bell curve shape. So standard data or standardized data that looks like this. Now what this is saying is that if you were to get data that's like this, you can actually break it up so that you can find specific areas of where your data might be. So what this says here, so if you have data in a bell curve, you'll find that 68% of it lies within this middle section here. Okay. Now in this middle section, we treat this middle section as the mean. Okay, and then what this section is here, where it moves, is referred to as a standard deviation. So this is saying that all of your data or 68% of your data is one standard deviation away from the middle. Okay, think of deviation as you going away from the middle. Okay, and that's why we need to know those two things, the mean and the standard deviation, because the standard deviation tells you how far you've gone from the middle. Okay, so you can see here, these are markings of one standard deviation. That's one standard deviation above and a standard deviation below the mean, which is the middle there. So all of this data here represents 68% of all of your data. So this is saying all of your data is one standard, 68% of your data is a standard deviation away from the middle, which is there. Okay, so that's the mean. Now, this bit here, similar concept, except now this time it's 95% of your data. So 95% of your data is 2 standard deviations away from the middle. So 2 spots away from the middle, whether it's going up or going down. Okay, and again, it uses standard deviations to measure how far it is from the middle, which is the mean there. And then the last one here is 99.7% of your data. So nearly all of your data is found within 3 standard deviations below and 3 standard deviations above. Okay, so the standard deviation again signifies how far you've gone from the middle. And if it's 3 above and 3 below, that's already 99.7% of your data. And then the last 0.3% from the middle are these. So these would be considered, I guess, 4 standard deviations away, which is quite far anyway. But the last 0.3 is beyond. Okay, and obviously, if you add all that up, they'll equal 100%. Well, actually, let me fix that up. If you add all of this up, it will equal 100% of your data. Okay, so what this bell curve, and this is really important that you actually refer back to this, is it shows you the distribution of your data. So how your data is actually grouped in terms of where it is on your bell curve. Okay, and again, the data has to fall into a bell curve shape for this to work. So let's look at some examples to make sense of this. Now, hopefully these will make sense as they are a bit challenging. And this is the kind of stuff that we'll expect you to do in Year 12. What also I would suggest is that you have a copy of this with you, or a blank copy of it, because I'm going to use it as a way to sort of make reference to do these questions, because you're going to be looking back at it a lot. So I'm going to put this here. So we have a copy of it. I'm going to draw on it as well so that we can make sense of it. All right, so the question here is, the wrist circumference of a group of people is known to be normally distributed, meaning, okay, again, that you can actually put it in a bell curve. Okay, with a mean of 17.7 and a standard deviation of 0.9. So this has given us the mean and the standard deviation. So remember, the standard deviation just tells you how far away you've gone from the middle. So 1 standard deviation represents 0.9 centimeters from the middle. All right, so before you actually start, what I would do with these questions is I would actually get that graph that we have as a reference point. And what you should do, or what you can do, is I normally write down certain labels here. So I know that obviously this data falls within a normally distributed data, so this will work. And I know that the mean is 17.7 and the 1 standard deviation is 0.9 from that mean. So the middle here, the mean, is going to be 17.7. So there's my starting point. 1 standard deviation away, okay, is going to be a 0.9. Now this is 1 standard deviation above, so that means this is going to be 18.6 because I've added 0.9. So at this point here, it's 0.9. Okay, again, another standard deviation above that, so 2 standard deviations away from the middle, which is 17.7. I'm going to add another 0.9 here, so it's going to be 19.5. That's this point here. Okay, so I'll put those markings there. And then another standard deviation, so 3 standard deviations away from the middle. Okay, you're going to add another 0.9, so it's going to be 20.4. right there. Okay, so I'm going to add these markings to make this question a bit easier for you guys. And then let's go the other way. Okay, so a standard deviation away from the middle, but going to the negatives, so minusing, this is going to be 16.8. Okay, because it's 0.9 away from the middle. Okay, again, another standard deviation. So that's two standard deviations now from the middle. So minus 0.9 and then minus another 0.9. So 16.8 minus 0.9 is going to be 15.9. And then lastly, one more standard deviation is 15 from the middle. So that's 3 standard deviations away from the middle there. Now, hopefully I haven't lost anybody, but we're going to look at these numbers as a range for where the data is. So you could say 34% of your data, for example, here is between 16.8 and 17.7. You could also say that 34% of your data is between 17.7 and 18.6. You could also say that 68% of your data right here is between 16.8 and 18.6. And that's how we sort of use these values, and hence why I've put them in there. So let's try and answer some of these questions. What range of values could 68% of the data lie between? So that's really easy. I already answered that. So 68% of your data lies between 16.8 and 18.6. Okay, so 16.8 and 18.6. Oops. Okay, what range of the data could the values lie between 47.5% of the data? Now, that is not explicitly listed in here, okay? But the interesting thing, okay, here is that some of your data will lie in between 47.5, but where is it here? Well, this is now where you have to focus on these percentages and figure out where it might lie. Okay, so this is where I would use my calculator. I've done a bit of this already, so let's see if I can make this a bit smaller so you can see all the data. Okay, there it is. Okay, let's see. So I might delete all this actually. So how do I find out where? Okay, in the next part here is where does 47% of my data lie, in what range? Now it says where it could lie, so it might lie in a few places, but in this case I would say actually no, in this case it would lie in a couple places. So let's add a calculator. So let's figure out where it is. Well, according to this here, there's 34% of my data and 13.5% of the data. Now it's asking for where 47.5% of the data could be. So if I add up 34%, so I'm going to work with this data here and this and possibly this. I'm going to add them up, and if it adds to 47.5, then that's where that data would lie. So 13.5 plus 2.35. Okay, a little bit too much. Okay, I'm looking for 47, so I might get rid of the 2.35. And there you can see that possibly 47.5% of your data could lie in between these two values here. Okay, so you would write here, it may lie between, okay, it could lie between 15.9 right there and 17.7. But also, and the tricky thing with this is that it could also lie between 17.7 and 19.5. Okay, because the question says where could. Okay, what range of it could 47.5% be? So again, looking at the percentages there. Okay, if I added 34% and 13.5, it would equal 47.5. So it could also lie between these two, 17.7 and 19.5. Okay, it could lie in between there as well. All right, so what percentage of the values between 15 and 8 could lie between 15 and 16.8? So that's really easy, because what you're looking at is what percentage of your data lies between this area. Okay, because it's 15 and 16.8. So you just got to add these decimals together. Okay, so my calculator, nice and easy. You're going to go 2.35 plus 13.5. I mean, if you didn't need a calculator for this, good. But the answer is 15.85%. Or it says 1 decimal, so we'll go 15.9%. What percentage of the values, next question, lies less than 18.6? So we're looking at less than 18.6. If this is 18.6, we're looking at all the data that's less than that. So all of this. Okay, so you're just going to add those percentages. So let's add them up. Okay, so you've got 0.15 plus 2.35 plus 13.5 plus 34 plus 34, which equals 84%. Okay, so that would be 84% for that one. Okay, last one. If there were 650 people in the group, how many people, question there, are expected to have a wrist circumference of larger than 20.4? Round your answer to the nearest whole number. So this is a bit tricky. Watch this one, okay? We're looking for how many will be above 20.4. So if 20.4 is here, everything above that is 0.15%. So that means you're looking for 0.15% of 650 people. So to do that, you're going to go 0.15 over 100 times 650. Okay, so just put that in your calculator. Oops. 0.15 divided by 100 times 650. Which equals 0.975, and you can round it to basically one person. Cool. All right, there is another example here. However, if you feel like you do understand what you need to do, you don't need to keep watching. You can now go ahead and actually do the questions for the exercise, which is going to be on. Let me just get it up here for you guys. It'll be on obviously what we've been doing on standardized scores, so 1.11b. But if you still don't quite get it, you may keep watching this other example that I will do. Okay, again, whenever you do these questions, really important, okay, that you get this graph as a reference point, because it will help you do the questions. And I really like to do this, especially if you're starting this topic brand new and you understand next to nothing about it. Okay, so question here is the concentration span of a group of adults is known to be normally distributed. Again, it's saying that it can be into a bell curve like this with a mean of 49 seconds and a standard deviation of 14 seconds. So that means the mean is the middle, which is 49. Okay, and every standard deviation away from that is going to be representing 14 seconds. So if you go above 49, one standard deviation, you have to add 14 seconds. So that's going to be 63. Okay, adding 14. Another standard deviation above that, add 14, is going to be 77. And then one more standard deviation above that, add 14, is going to be 91. Okay, so there's your standard deviations above, and then let's go below. So one standard deviation below is going to be minus 14. So that'll be 35. Okay, another standard deviation from there. So it's two standard deviations, is minus 14, minus 14. So 35 minus 14 is going to be 21. Okay, and then from there, another standard deviation from 21. So it's going to be 3 standard deviations, which is here. It's going to be 7. Okay, so there is the data that I'm going to use as a reference point to do these questions. So what range of the data could the values where 95% of the data lie? Okay, so I just butchered that question, but where is 95% of the data? What's the range? Well, it's between 21 and 77 seconds. So 21 and 77 seconds. Next one, where could 81.5% of the data lie? Okay, tricky one there. By the way, just a heads up, in case you didn't know, this here in the middle, if you split this in half, that's 50% of your data. So that's 50%, and that's also 50%. So that's just a helpful thing for you guys to also understand when reading these. Okay, where is 81.5% of the data? Now, the reason why I brought that thing up just before is because I know that if this is 50%, okay, if I added 34, that would give me 84% of the data. So it's a bit much. So what I'm going to focus on here is maybe it might lie in between 2.35 and here, this data. So if I add all that up, okay, if I add all that up, so you've got 2.35 plus 13.5 plus 34 plus 34. That gives us 83. So it's a little bit much still. Okay, so what I might get rid of here. So I'm trying to find out where 81% of the data could lie. So it could very well be over here. Okay, so let's just add that up. Get rid of the 2.35 here. Oops. Okay. And there you go. Okay, I've got 81% of my data lying between 21 and 63. But on the flip side, 81% of your data, okay, could also lie between 35 and 77. Because notice how this is basically a mirror copy image of this, or it's a mirror image. So there's actually two ranges there. So between 21 and 63. Here it is, 21 and 63. Okay, I don't need that anymore. And also, so we determined that it could lie between 21 and 63, or it could also lie between 35 and 77. Okay, what percentage of the data, of the values, is between 35 and 91? Around your answer to the one decimal place. So we're looking between 35 and 91. So you're looking at all of this. Between 35 and 91, we're going to add these decimals. Okay, so let's do that. 34 plus 34 plus 13.5 plus 2.35, which equals 83.85. We're going to round it to one decimal. So 83, I forgot it already, 0.9. Yes, okay, percent. Okay, next one. What percentage of the values is greater than 21 seconds? All right, so you're looking at how many of the values are greater than 21 seconds. So that means you're going to add all of this. All right, so on my calculator, let's add them all up, all the percentages. It's going to be 13.5. If you can see a shortcut to this, guys, I would highly recommend that you do it. 0.5 plus 2.35 plus 0.15, which is 97.5, okay? Now, in terms of the shortcut that I was talking about, again, you can actually just refer to the numbers down here. Okay, down here. You know that all this, so remember you're focusing on this, yeah? You're trying to add all this up. If you look here, 95% of your data is within these two, okay, these sections here. So what you can do is you can just add 95 plus these two numbers, and that'll give you the straight answer of 97.5. Last one, if there are 480 people in the group, how many people are expected to have a concentration span between 7 seconds and 63 seconds? All right, 7 seconds and 63 seconds. So you're looking at between 7 and 63, which is there. So that means you're going to add all of these percentages here. Or actually, we probably should have been doing it like this so you guys can make sense of it more. But yeah, all of this basically between 7 and 63. So you're going to find a percentage of 480. So let's add them up. How much is that in terms of percentage? So that's going to be, well, I can go using my shortcut. Okay, that's 68 plus 13.5 plus 2.35. So 68 plus 13.5 plus 2.35. That'll equal 83.85. So you're looking for 83.85% of how many people? 480 people. Okay, so let's do that. So that's going to be 83.85 divided by 100 times 480. What does that equal? Divided by 100 times 480. And that equals 402 people. Okay, so that means 402 people have a span or attention span or concentration span of between 7 and 63 seconds. Now, thank you if you've made it this far. Well done. Hopefully all of that has made sense to you all. But that is it in terms of standard deviations and means and distributions. If this still doesn't make sense, would recommend you guys that you rewatch this. Okay. Thank you very much. Have a good day.